Welcome to the Explainer. Have you ever wondered how these massive global applications, the ones that millions of us use every day, how do they stay secure? How do they stay online? Well, today we're going to pull back the curtain and build the architectural blueprint behind them step by step. All right, so let's put on our architect hats for a second. Imagine this is your job. Build a brand new application. It's got to be public facing, right? So anyone, anywhere can use it. But you also have to protect its most sensitive data. And it needs to handle crazy, unpredictable traffic spikes without crashing. So where do you even start? It's a big ask. The solution isn't some flashy, brand new technology you've never heard of. Nope. It's a classic, foundational pattern, a pattern that has literally powered the internet for decades. And we're going to build it out together right now from the ground up. Okay, first things first. Before we lay a single virtual brick, we've got to understand the blueprint we're working from. And that is the classic three-tier application.
So the core idea here, it's really powerful, and it's called separation of concerns. All that means is we're going to break our app into these distinct layers, or tiers. Each one has one job and only one job to do. And believe me, this is not just about being tidy. It is the absolute secret to making our application more secure, more scalable, and frankly, a whole lot easier to manage down the road. So let's meet the three tiers, shall we? First up, you've got the web tier, or the presentation tier. This is everything your users see and interact with, the website and their browser. Then behind that, you've got the application tier. This is the real brains of the operation. It's where all the heavy lifting, all the business logic actually happens. And finally, we have the data tier. Think of this as the secure vault, the database where all the important information is stored and managed. They all work together, but, and this is key, they are kept distinctly separate. Okay, we've got the blueprint. Now let's start building. For this example, we're going to be using AWS. And our very first step is to carve out our own private, totally isolated slice of the AWS cloud. The first thing we're going to do is create something called a virtual private cloud, or a VPC. Now, the easiest way to think about this is like it's your own personal data center, just floating in the cloud. It's completely walled off from every other customer. Then, inside that data center, we start partitioning the space by creating subnets. You can just think of these as the different secure rooms inside our building. Now, here's the crucial part. Not all subnets are created equal. We're going to create public subnets for anything that absolutely has to face the public internet. But, and this is a big but, for all of our sensitive backend stuff, we're going to put that in private subnets. These have absolutely no direct route to or from the internet. And that isolation, that is our first and maybe our most important layer of defense. All right, so we've built our secure rooms. Now it's time to actually furnish them, right? Let's take our application components and place them into their designated tiers. And here is where it all comes together. Check this out. User requests from the internet, they only ever hit our load balancer, which sits in that public subnet. That's our single front door. The load balancer then passes the request on to our application servers, which are safely tucked away in a private subnet. And then only those app servers are allowed to talk to the database, which lives in its own, even more secure private subnet. You see that flow? It creates this layered system where there is absolutely no direct path from the wild west of the internet to your precious data. Okay, our components are in place, and we've got our basic network isolation setup. That's great. But to build a true fortress, we need to add some more granular, more detailed layers of security. So, to build this fortress, AWS gives us two primary tools. We have network access control lists, we'll just call them NACLs, and we have security groups. Now, I know they might sound kind of similar, but they have very, very different jobs. And the real key is learning how to use them together. Here is the absolute best way to think about this. Network ACLs, they're like the high, thick castle wall that surrounds an entire subnet. They're your first line of defense, filtering traffic before it even gets close to your servers. One quirky thing about them is they're stateless, which just means you have to explicitly create rules for traffic coming in and going out. Now, security groups, they're different. They're like the personal bodyguard, standing right at the door of each individual server or database. They're stateful, which is awesome, because it means if you let traffic in, the return trip is automatically allowed out. See how that works? Using both gives you this incredible layered defense in depth. All right, so we've just designed and secured a classic three-tier app in AWS. That is a fantastic skill to have, for sure. But
what happens when your next project isn't on AWS? What if it's on Azure or maybe Google Cloud? I mean, just take a look here. The names are all different, right? AWS has its application load balancer. Azure has application gateway. GCP has cloud load balancing. But they all do the exact same job in the web tier. It's the same story for compute. An EC2 instance, a virtual machine, a compute engine instance. At the end of the day, they're all just servers for your app tier. The names change, but the fundamental pattern is universal.
And this, right here, is probably the single most important takeaway from this whole thing. Don't waste your brain power memorizing a million different product names. Seriously, those are just details you can look up in 2 seconds. What makes you a real cloud architect is deeply, truly understanding the patterns. These patterns, like the 3-tier architecture we just built, are what work everywhere. That's the real skill. So this classic pattern, it really is the bedrock of so much of the internet we use today. It's a proven fortress. But of course, technology never stands still, right? As we move into a world of containers and serverless, our architectures start to evolve. The core principles, things like separating concerns and layered security, they're still absolutely crucial. But how we implement them, well, that starts to look very, very different. And exploring that, well, that's a journey for another explainer.